Welcome to ChemHelp ASAP. Let's name some alcohols. Alright, so alcohols. There are really two ways that we're going to name alcohols. When I say alcohols, I mean the OH group. The first way is to have name the alcohol as the base name of the molecule, and we'll use the suffix OL. We'll stick that on the end of the name, and then we'll be done. Sometimes we need other things to be the base name, so we have to include the alcohol as a prefix form. We name the alcohol as a substituent on the molecule. It's less common, but we'll see both in this video. So, for our first example, here is a one-carbon molecule. And one carbon molecule, we would call this methane, but it has this OH on it. So what we'll do is instead of methane with an E on the end, we'll drop the E and add OA, or OL. It's methanol. Let's go crazy, one carbon bigger. This is a two-carbon chain. It will be ethane. We keep the the AN tells us it's still an alkane. Drop the E on the end, add an OL, that's ethanol. One carbon bigger. And I'm numbering these carbons because that's going to be important. So this is a propane. We drop the E on the end, add OL, and we get propanol. Now, there are two places we could have the OH on a three-carbon chain. We could have it on an N carbon. That'd be the 1 position. So we have to say it's in the 1 position. It could also be in the 2 position, in the middle. So we have to specify sometimes where our substituent is. That's not a new idea for us. But there's 2-propanol. Now, sometimes when we name, we can have other substituents in the molecule, of course. So this is an alkyne. So this is a 4-carbon chain. The 4-carbon chain, it's not an alkane, it's an alkyne. So we would normally think of this as some kind of butane. Much like we saw with the alkanes, though, we're going to end up dropping this E and adding an OL. So this is actually going to be a butanol, or I'm sorry, a butanol. But now we got to do a couple things in here. One, the butane is gets relegated to the 3 position. Turns out the alcohol is a pretty important functional group, and it dictates where you number the chain. So we will number the chain so that the alcohol is as close to the end as possible. And it turns out it's on the end. So we have a butane in here, and if we number it so that the alcohol is on the end, then it's 1, 2, 3, 4. The alkyne starts at carbon 3. So it's a 3-butane. And then where do we stick the number for the alcohol? Well, we got to kind of insert it right after the alkyne. So we know, where's the alcohol? The alcohol is at position 1. Where's the alkyne? The alkyne's at position 3. And of course, we can get additional substituents in our molecules. We can have a chloro. So this is some kind of butene. It's a butanol. The alcohol will number this, so the alcohol is as close to the end of the chain as possible. And now out in front, we'll have 2-chloro. And now we have to get our butanol. So where's the alkene? The alkene's at position 3. 3-butene, 1-ol. Where's the alcohol? It's a position 1. Where's the alkene? It's a position 3. And of course the chloro is on position 2 of our bute chain, our 4-carbon chain. Sometimes molecules, and we won't draw one that's really complex, but sometimes it's handy to be able to say, this isn't an alcohol, this is it has hydroxy groups on it. So you can imagine naming this as a cyclohexane, and then saying, okay, we have 2 hydroxy groups on it. Those are 2 OHs. And you could, whoops, let's fix that. We want to call this 1,2-dihydroxy. Dihydroxy cyclohexane. People wouldn't call it that. They'd probably call it 1,2-cyclohexane diol. But sometimes we need to put the hydroxys out in front, name them as a substituent, because there's something else that's the VIP that sits at the end of the name. So these are just A couple quick examples. We're not experts in naming alcohols, but at least if we encounter names of alcohols, we can look at them intelligently and read them and try to get a structure from those names.